is Reddy from Intel.
All right, welcome to our full day session for composable memory systems. We have a full agenda and thanks for being the early risers and strong support of memory systems. What I'm going to do is basically we just want to go over what all things composable memory systems is doing, what's the composition of work streams, and then make sure that actually we talk about what our deliverables are for composable memory systems is a sub-project within a server project, and we focus primarily on memory configurations for general purpose compute as well as for the AI systems. So we'll give a little bit overview of where we started, where we are right now, and then work through what the deliverables that we have for this year. Just quick update on as we go through the day. We have full day agenda going up to 4 o'clock, and it's quite tight schedule. So me and Reddy will be sitting here. We'll try to manage the time as much as we can. There's a timer here for the speakers, and we'll give some updates on how much time we have left. So a CMS overview. Some of you guys who have been here for last 2 years, perhaps this is not a new thing for you, but the whole idea was to, as we start looking at a memory challenges in front of us, we wanted to make sure that we have solutions talked about how do we compose memory, how do we have configuration for multiple tiered solutions that we can talk for the different applications, what the applications are driving these kind of use cases, how do we make sure that the industry is involved into building the benchmarks and workloads and profiles, and build the solutions and bring it as in the open way as much as we want in OCP for hardware as well as software. So this is where our overall blueprint that we defined, that we'll talk about use cases, we'll talk about what's the system architecture for such composable memory work systems, and then give the industry workloads and benchmarks to validate the solutions that they want to bring it to the market for the composable memory subsystems that applies to the use cases that we talked about, and this all has to be coming together with management framework. We also expanded our work to make sure that we feed into the academic industry and make sure that the work continues into the academic industry. We want to make sure that actually that we work with the industry. There are a lot of standards bodies working in different areas, JEDEC, NIA, DMTF, UEC, UL, this list continues to expand. OCP, we are not defining the standards, but we are defining what the use cases and what the solutions that are being brought forward. So we want to make sure that we collaborate with the groups that are actually defining the standards and make sure the overall solutions are enabled. So that's the overall idea for composable memory system. Everything related to the memory, whether it is compute, general compute systems, AI systems, storage system, everything that has memory inbuilt, what the solutions are there, how do we build them? Some at a high level when we started, we looked at saying that where are the solutions? We have one way of connecting memory right now, which is you have a DDR or LPDDR or some direct memory that is connected to CPU. There are more ways that are coming along, which allows you to tier the memory. One of them could be the direct attached CXL or any other memory fabric that comes. No, this one didn't go. For some reason, this whole picture is not coming through. Now you can imagine, I'm going to talk about through a picture, which is basically direct attached memory, or we have a pooled memory where you can have multiple hosts connected to a memory that are sharing pooling the capacity, dedicated capacity for each one of them. Or you can have those servers or end nodes connected to a pooled memory, but now they are sharing. There is a common memory that can be shared in a consistent way for the use cases that they have. And then fabric memory, where you just have the whole memory fabric created and memory sits as end nodes and they connect to each other. It's a quite visual. You can download the presentation later and you will have access to that. History, where we started long time back as a FTI or Future Technology Initiatives. A few of people came together. We started, it became a sub-project, and now where we have very strong membership, we have more than 250 people who are member for the group. We have every weekly calls where more than 40 people to 50 people join every week on a Friday, 9 o'clock. So there is a strong commitment from people, significant amount of contributions being done. This year we already have published specifications. We have published white papers. We have published GitHub code for the memory fabric as well as for the workloads and the benchmark. So there's a lot of contributions coming from the member community. And as we start looking into going beyond general purpose computing, but looking into the AI system has a significant challenges that the whole community is bringing forward. Use cases that we are bringing forward, whether it is a accelerator memory expansion through the host, accelerator direct attach expansion, fabric attached memory, all the AI related use cases, and expanding into what kind of memories can be used, how can they be influencing our decisions for what goes into the AI clusters and how it solves the AI memory wall problems, whether it is capacity or bandwidth. All of this is being discussed on a weekly basis, and we are quite excited to see how much work we can do. The work was significant, so we ended up distributing the work across 5 work streams. Let me hand it to Reddy to talk about work streams and what we are going to do this year.
Okay. So like Manoj said, we split the work stream based on the actual CMS charter. Obviously, we need to start off with what are the use cases that hyperscalers, the next wave customers actually see. And we have essentially focus on the use cases. And then we have focus on the workloads. So once we have the use cases, we need to have a set of targeted workloads. This includes general purpose compute as well as the AI and HPC, as 2 distinct focus areas. For us to actually build, a total solution, we do need data center-wide composable memory orchestration framework. This is actually building on top of DMTF, the standards, but able to actually compose memory dynamically for each one of these workloads. Then the third one is, like Manoj said, we have actually beefed up our focus this year on AI and HPC. Fabric is a very critical component for AI HPC, specific workloads. Computational programming is something that we do want to target, so we are not losing track of what is happening today, but we are also focusing on what's happening in future. We do believe that computational programming is going to be one of the key aspects of driving the system-wide optimizations for AI workloads as well as the general purpose workloads. And then academic research is something where we want to keep an eye so that we essentially know what's happening in the academia and we can actually provide feedback. So there is a bidirectional communication with academic research community as well. So that's the way we segmented these different focus areas into work streams. Each one of them have work stream leads, and they're actually going to talk today. For each one of them, you're going to see specific, focused presentations as well. From our, this year and the next year, our focus is going to be on the composable workloads. We need to focus on both general purpose as well as AI specific workloads. You probably heard about the caching on the Redis, Memcached, Cassandra, Spark. CacheLib is essentially a caching embedded caching library, open source library. So we would be focusing on the general purpose. You're going to see quite a bit this year, but come next year, you are probably going to see more of AI and HPC. Data center memory orchestration is more about how do we actually stitch together all the way from the Kubernetes type of orchestration down into specific node and compose memory on the node. So how do we stitch all the DMTF and CXL standards along the way and have a white paper to cover those aspects, implementation aspects. AI and HPC, it's the target is to have an inference white paper and also focus on the end user use cases and more clarity on that by having a logical system architecture that actually supports AI and HPC as well. Computational programming, immediate focus is really educating on what exactly are the opportunities on the computational programming through the white paper as well as the blog. Academic research, we will have a blog coming up. We were targeting this summit, but we pushed it out to sometime after the summit. And then there are broad horizontal specific initiatives like Manoj said, hardware, software, co-design initiatives. Composable memory app plan specification actually got published thanks to Seagate, who drove that. So there will be more and more of that in the CMS. There was a proposal from one of the key contributors, from Brian, to see if we can actually have memory tiering contest. Basically say, take the workloads that we have defined and actually promote the vibrant ecosystem on the device vendors as well as the total solution vendors to actually participate on demonstrating the memory tiering not just the concept, but also the performance attributes and everything else. So that is still in the works. And last year we did the Memory Access Tracker, ECN, through CXL Consortium. This kind of highlights our work with others, standards bodies, like Manoj said. And there is also a white paper that was published. So I strongly encourage you guys to take a look at all the white papers that have been published so far. They are actually on the wiki, CMS. From the logical architecture view, essentially we look at compute as one building block. It can be general purpose compute coming from CPU, or it can be coming from the GPU. So those are the consumers of the memory. And the concept is you have near memory. So this could be, if it is a CPU, you're essentially talking about DDR, remote NUMA socket memory, or CXL directly attached memory, one hop away. If it is GPU, you're talking about high bandwidth memory or LPDDR, whatever you have, right? For memory is something that where you essentially have fabric attached memory. So there is a little bit of nuance from the performance, the bandwidth, attributes. So we essentially segregated them into near and far, and then you have the storage as really the element of, storing some, large content, right? So that's kind of how we segregated them in the system architecture. Oops. So clicking down on the logical architecture view, I won't go into the details of each one of them. There is a white paper that actually explains all the details about each one of these building blocks. But in general, the theme is you essentially have compute element, and then there is also a management controller. We didn't want to have very implementation view, so this is more of a logical view, so you don't see that as a baseboard management controller, but technically it is BMC, right? Managing the host, and then there is an out-of-band connectivity to the data center orchestration, and then you have CXL based implement. If you look at the CXL based memory expansion capability, you can actually attach it to the host directly, or you can actually share among multiple hosts, or it could be coming from the fabric, right? And then, last but not least, there may be a memory enclosure sitting somewhere on a different transport, completely nothing to do with the CXL and PCIe. So we are essentially looking at accommodating all these usage models in the logical system architecture. From the workload focus areas, I briefly outlined before, we will continue to focus on the general purpose compute, looking at the caching related workloads, streaming related workloads, Spark and Presto, data analytics, Cassandra, and so on. But we'll also increase our focus both in the training and the inference workloads. And then as and when time permits, we'll extend the focus to HPC as well. Currently, we are not focusing on HPC because we have so much of work in front of us. And you're going to see that today. Vikrant and company are going to present. There are two topics, if I remember correctly. So I strongly encourage all of you to actually participate in the weekly meetings. So we meet every week on Friday. So that would be my request to all of you to come and join, take a look at that. Last but not least, we also want you to actively drive some of the key problem areas. Things like how do you take advantage of inference workloads with fabric attached memory? How do you speed up the inference using a GPU and CPU resources collectively with the pooled memory resources? How does the orchestration need to shape up in that type of architecture? So there are a lot of deep dive discussions on these. So if you are really an AI expert, we want you to actually attend and contribute as much as possible. All the details are actually on the CMS project wiki. It's updated with meeting minutes, latest white papers, all the latest presentations. Everything is within the is actually posted in the CMS wiki. Also, you can subscribe to OCP mailing list, so you essentially get an idea of what's happening. And if there are specific topics that you are interested, where we have a discussion going on, you might as well join selectively if that is what you prefer. But that's another option. I think that's pretty much what we have. Yeah. Manoj, yeah.
That's about it. I think we are perhaps going to return 3 minutes so that we can start working on the next presentations. We have next, Vikrant. Okay. All right. So we'll start. Thank you very much, guys.
Thank you.
Please join the work, and I think let's drive the memory solutions for the systems.
Thank you.
So we can take Q&A. I think we can answer the question of Q&A. But based on the time, I know we are going to have a tight schedule, so we'll try to take time questions as much as possible. Otherwise, at least at the end of each session, we'll give some time so that we can have a discussion.